Graphs of quadratic functions. A quadratic equation is always written in this form, like ax squared plus bx plus c equals 0, where a is not equal to 0. The graph of the quadratic function, if we graph it, will be a parabola, so a U-shaped graph like these here. The coefficient a determines if the graph opens up or down. If a is greater than 0, then the graph is going to open up. If a is less than 0, then the graph opens down. So if a is positive, it opens up. If a is negative, it opens down. And so if we look at these two pictures, notice here that the number in front of x squared is positive 1, and that's why the graph opens up. And on this side, the number in front of x squared is negative, and that's why the graph opens down. The vertex of the graph is the lowest possible point, which we call a minimum. So in this case, this would be your vertex. And in this example, the vertex is located at 0, 0. And in this example, the vertex is the maximum height, the maximum point of the graph. And so in this point, the vertex is also located at 0, 0. In the previous section, we saw that the solutions are called zeros, or x-intercepts, or roots. And these can have one solution, two solutions, or 0 solutions. Label the vertex, x-intercept, and y-intercept, and find the solutions graphically and algebraically. So the vertex is located down here. That's the minimum point of the parabola. And it's located at 0 for x, and y is negative 4. The x-intercepts, or we call them zeros, are where the graph crosses the x-axis. So these are my zeros. And that's going to be at x equals 2 and x equals negative 2. The y-intercept is where the graph crosses the y-axis. And for this, the value of x is always going to be 0. So here's my y-axis, and the graph crosses the y-axis at this point, which is negative 4. Notice that the y-intercept and the vertex are the same, and that's not always true, but in this example, they came out to be the same. Algebraically, we would find the zeros by taking the equation, setting it equal to 0. I can use the square root property, add 4 on both sides. And so we get x is equal to plus or minus 2, which are these two answers here. Find the solutions for the quadratic equations. So here, the solutions, again, just means to find the x-intercepts. So that's one solution, and this is another solution. So we say the solutions are x equals 1 and x equals negative 1. And for this one, notice this is your x-axis down here, and the graph does not cross the x-axis. So we say that there's no real solution. We have to say the word real because there are solutions, but they're not real. They're complex solutions. These two examples I saw come up on the exam all the time. And so, which could be the equation of the quadratic graph below. So you want to eliminate some of the possibilities here. For example, you know the graph is opening down. So if we look at our choices, we know that the number in front of x has to be negative because it opens down. So I can eliminate letter A, letter C from my answer choices. And then the next thing I would do is work with the y-intercept. The y-intercept is a negative 3. So anytime that you have a quadratic equation that's written in this form, this number here is going to be your y-intercept. Because if you let x equal 0, then all of this becomes 0, giving you the c. So your y-intercept is at 0, c. And so in this case, your c is negative 3. So from the ones that are left, I know that 3 has to be negative, so I can get rid of letter B. So now I have letter D and letter E. And so now what we can do is pick another point. Let's say I use the vertex, and the vertex is x is 2 and y is 1. So this is my x and this is my y. So if I plug in the 2 for my x's here, let's do letter D first. F of 2 is equal to negative 2 squared plus 4 times 2 minus 3. So that's negative 4 plus 8 minus 3. So negative 4 and negative 3 is negative 7. So we get 1. So that gives me the vertex 2, 1. So that works for this one. But you want to check it on the next point as well, just to make sure. So if I plug in a 2, then we get negative 4 minus 8 minus 3. And that gives me a negative 15. So notice it doesn't work for E. So my answer is going to be letter D. You could have also used these points here. So let's try number 36. So now I know that the graph is opening up. So since it opens up, I can eliminate B and C. My y-intercept is at 0, negative 12. So I can eliminate letter D, and I'm left with 2. I can use my vertex, but notice my vertex is a decimal, so that might be take a little bit more time. So I'm going to go ahead and use 3, 0. So if x is 3, 3 squared minus 3 minus 12. 3 squared is 9 minus 3 minus 12. 9 minus 3 is 6 minus 12 is equal to negative 6. Since I entered 3 and I didn't get 0, that means that that's not a solution. So that's out of the picture. So my answer is letter E, but we can check it. F of 3 is equal to 3 squared plus 3 minus 12. So we get 12 minus 12 is equal to 0. So I always try to eliminate answers that are, try to eliminate choices that we can, so that we can work with fewer choices.